Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's notes are on 1.5, Describe Angle Pair Relationships. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So the first thing we need to do is know what it is that they are talking about. So what do these vocabulary words mean? Just move that over a little. Okay. So the first vocabulary word is complementary angles. So when I used to teach middle school, I had my kids come up with a few different ways to memorize the difference between complementary and supplementary angles. And they came up with a few different mnemonics to help them memorize. So one of them is they said that it is right to compliment people. It is right to compliment people. So complementary angles add up to a right angle. They add up to 90 degrees. Complementary angles, it's right to compliment someone, right? 90 degrees. Another thing that they said is that since complementary angles add to 90 and supplementary angles add to 180, they said that C comes before S in the alphabet. And they said because C comes before S and 90 comes before 180, that just made sense. Another thing they said is that an S is truly just two C's put together. If an S is two C's put together, it is twice complementary, right? So complementary is 90, supplementary is 180. Another thing that my students came up with is that it's easy to make a 90 out of a C. You can make a 90 out of a C, and you can make a 180 out of an S. Whatever it is that you do to memorize that complementary angles add to 90 and supplementary angles add to 180 is fine with me, but those are just some different ways that might help you to memorize the difference and not confuse them. All right, so those are your first two vocabulary words. Another vocabulary word is adjacent angles. Adjacent angles are two angles that are next to each other. They share a common vertex and leg, but no points in their interiors. Once again, adjacent angles are two angles that are next to each other. They share a common vertex and leg, but no points in their interiors. Adjacent angles are angles that are next to each other. They share a common vertex and leg, but no points in their interiors. All right, so let's identify a pair of complementary angles. Does anyone see a pair of complementary angles here? Two angles that add to 90? Yes. CAB and RST. Angle CAB and RST. Perfect. 58 plus 32 is 90, so those are a perfect pair of complementary angles. How about a pair of supplementary angles? Can anybody identify a pair of supplementary angles? Yes. You said BAC? DAC. Okay, so DAC and RST. Perfect. 122 and 58 do add to 180. These two angles together do add to 180, so they are a supplementary angles. They are a pair of supplementary angles. Good job. How about adjacent angles? Did anyone see any adjacent angles here? Yes. CAD and CAB. Perfect. They share a common leg and vertex, but no overlapping degrees, no points in their interiors. So this angle is adjacent to this angle. Wonderful. Perfect. So let me show you something that is not adjacent. So BAC is not adjacent to BAD. They do share a common leg and vertex, but they have overlapping degrees. Does that make sense? That whole angle, this portion here is inside of the whole angle. You cannot have overlapping degrees. All right, so name a pair of complementary angles. Can anybody give me a pair of complementary angles from this diagram? Yes. FGK. GKL. Is 41 and 49 equal to 90 degrees? They are, so that is a perfect pair of complementary angles. Good job. Can somebody give me a pair of supplementary angles? Two angles that add to 180, yes. HGK and L what? LKG. Do those add to 180? They do, so he is correct. Those are a Great example of a pair of complementary angles. Supplementary angles. And then I also need a pair of adjacent angles. Can anybody find some adjacent angles here? Yes. FGK. And what? KGH. Perfect. They share a common vertex and leg, but no points in their interiors. They don't have any overlapping degrees. Wonderful. That is a pair of adjacent angles. So, our angles KGH, KGH, this angle right here, and angle LKG, LKG, and this angle right here, are these two angles adjacent? No, they do not share the same vertex. They share the same leg, but not the same vertex. So no, they are not adjacent. Our FGK, let's do a different color, FGK, so this angle here, and FGH, FGH, are these two adjacent? No. They share a common leg and vertex, but they have overlapping degrees. These 41 degrees are inside of this whole angle. You can't have overlapping degrees. Given that angle 1 is a complement of angle 2, and the measure of angle 1 is 68 degrees, what is the measure of angle 2? So complement means what? That they're complementary, so they add to 90, because it's right to complement, people. 90 minus 68. What? 22. Good job. So angle 2, the measure of angle 2 is 22 degrees. What is the supplement of 56? If 3 and 4 are supplements, and 4 is 56, what is angle 3? What do I do? 180 minus 56, 124, 124 degrees. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles. So that means that this is a linear pair, right? They're 180 degrees. This is a straight angle. Find the measure of BCE. So they want to know what is the measure of this angle and what is the measure of this angle. Well, in order to know that, I have to solve for those angles, right? So the only thing I do know is what? What do I know? There's one thing I know, that they equal 180. So 4x plus 8 plus x plus 2 must equal 180. So that's 4x's plus 1x is 5x's. 8 plus 2 is 10. We're just combining like terms on the same side. Now we need to get rid of whatever's on the same side of the variable that is not attached to it using inverse operations. So we're going to subtract 10 from both sides. We bring down our 5x, bring down our equal sign. 180 minus 10 is 170. Divide by 5 on both sides because we're going to take care of whatever's attached to the variable using inverse operations. It's being multiplied. The opposite is division because any number divided by itself is 1. So 1x, or x, equals, 5 goes in there 3 times, would be 15. So that would be 60, 70, so 20 is left, so 5 goes into 24 times. So x is 34. 34 plus 2, we got 36, which makes this 144. So when you plug in 4 times 34 plus 8, you better get 144 or you did it wrong because they need to add up to 180. Given that angle 1 is a complement of angle 2, and angle 2 is 8 degrees, what is the measure of angle 1? Angle 1 and 2 are complementary. They're complements. If angle 2 is 8 degrees, what is the measure of angle 1? 82. Complementary angles add to 90. One of them is 8. 8 plus 82 is 90. Angle 3 and 4 are supplementaries, right? They're supplements. So if angle 3 is 117, what is angle 4? (63 degrees). Good job. And try our next one. if the measure of angle LMN and the measure of angle PQR are complementary angles. Find the measure of the angle if the measure of angle LMN is 4x minus 2 and the measure of angle PQR is 9x plus 1. So take a second or a couple minutes to figure out this problem, and then we will go over it. I'm going to pause the video. Alright, so what you guys should have done, since they're complementary, they add to 90 degrees. So you're going to set these equal to 90. So 9x's plus 4x's is 13x's. Negative 2 plus 1 is negative 1. And you're setting those equal to 90. So you're going to add 1 to both sides. So 13x equals 91. You're going to divide by 13 on both sides. What do you get when you do 91 divided by 13? You get what? 7. So x equals 7. Plug back in. 7 times 4 is 28. 28 minus 2 is 26. 7 times 9. 9 times 7 is 63. 63 plus 1 is 64. Do 64 and 26 add up to 90? They do, so we know we didn't mess anything up. Identify all of the linear pairs and all of the vertical angles in the figure at the right. So, linear pairs, pair of socks, pair of shoes, right? Pair means 2. So linear pair, 2 angles that form a straight angle, right? So linear pair are 2 angles that form a straight line. A linear pair is 2 angles forming a straight angle. It cannot be 3. So, can you guys name me a linear pair from this diagram? Sorry, the thing's just popping up. A linear pair. 2 and 4 do not form a straight angle. 2 and 5. No, because angle 3, what about those degrees that are missing? 4 and 5 are a linear pair. They are 2 angles that add up to 180. They are adjacent, right? 2 adjacent angles that are supplementary are linear pairs. 2 adjacent supplementary angles are linear pairs. There's one more set of linear pairs in here. You guys see them? 1 and 4. 1 and 4 are 2 angles that form a straight line. They are adjacent and supplementary. They are a linear pair. All right, so how about vertical angles? Vertical angles, if you guys look up here at me with my pens. All right, so we got these 2 pens. So if I cross them, you can see this, the top and bottom angles, these 2. Those 2 are vertical, and these 2 over here are vertical. So when I open these up, those 2 on the top and bottom are getting larger. Now they're getting smaller. They are always congruent. So vertical angles are across from each other when 2 lines intersect. They're congruent. Vertical angles are across from each other when 2 lines intersect. So look at these 2 intersecting lines. Angle 5 is across from angle 1. They are vertical angles. They are congruent. Those are the only 2 examples. That's the only example of vertical angles in this diagram. Two angles form a linear pair. Okay, so we have 2 angles forming a linear pair. The measure of one of the angles is 5 times the measure of the other angle. What are the measures? Well, let's think about it. Linear pairs add to what? 180. So 5x plus x, or 6x, equals 180. So x has to be what? 30. So we have 30 degrees, and 30 times 5, 150 degrees. Do 30 and 150 add up to 180? Yes, so I know I did it right. Not too bad, right? Do any of the numbered angles in the diagram below form a linear pair? 2 angles that are opposite each other when 2 lines intersect, they're congruent. Angle 1 is vertical with who? 1 and 4. Angle 2 is vertical with who? 2 and 6. They're across from each other. 2 and 5. They are across from each other when 2 lines intersect. They're these 2 intersecting lines. All right. Another one. 3 and 6. All right. Those are your linear pairs. Did I just say linear pairs for those? What am I thinking? Did I say linear pairs or did I say vertical angles? I said linear pairs? scratch that. I'm talking about vertical angles. So 1 and 4 are vertical, 2 and 5 are vertical,